That was a blanking plate. It was blanking off a port on a cylinder block on a traction engine, just a bit of flat bar with 2 holes in. I was asked if I could make something that looked a little bit better out of this piece of brass, so I picked the two centres up and spot drilled them, and all I've done, I've drawn 3 circles, 2 small ones and 1 big one in the centre, and you simply join the tangents up with straight lines and you get a nice oval shaped flange. So I'm going to drill 2 holes and I'm going to try and cut it to shape. I'll probably use a slitting saw and then take it outside and finish it off on the disc sander. And it must be 15mm thick. It's a nice bit of brass. It'll look much better polished up with 2 brass nuts on than that, which just looks like somebody who didn't really care what they were doing. So we'll get these 2 drills. Just to mark them, all I did, I clamped those 2 together and put a good fitting drill through, so I've got the 2 centres. Going to put that spanner through there. I won't, but if you break through and you go diving into the bed, it's not ideal. It just takes something simple like that to stop it from happening. It's decent quality brass, you can tell the way the swarf's coming out. Excellent. You can see the shape I've drawn there is a big circle in the centre, only chained, and it just sort of, it's going to look a lot better. That's a decent bit of brass, that. Wouldn't like to buy it. Not exactly precision engineering, but it's quick and it works. Put a little vise on the corner of this bench. It's ideal for grinding out here, for the making a mess. Doesn't really matter. I bought this sanding disc quite a while ago when I was doing a lot of pattern making. It's ideal for sanding drafts on wood, but I found it's also very effective at removing metal, especially soft metal like brass. Cleans it up really nice. want to take the sharp edge off this so it looks like it's a little bit older than it actually is. Once it's been polished a few times. Start full. That's like a fibre wheel, like a really coarse Scotch-Brite. This is a proper buffing wheel. Really good finish on very quickly. I'm sure you'll agree that that's going to look a lot better than that. And it gets its brass nuts on as well. But I think it's the big ones I made. This is a lathe compound slide off an old Wadkin pattern maker's lathe. It's probably 110 year old, and the problem I've got with it is it's clean broke through there. Don't know how it broke, but it's certainly broken off. It's obviously cast iron. It's quite critical as well. It goes back together the right place because it's got a lead screw running through there. So this is actually the mounting for the lead screw. The handle will go onto there. It is a nice clean brake, and it does fit together really nicely, like that. So I think what I'll do is I'll use this as a jig, and I'll V out the two corners and stick it together using silicon bronze filler rod, probably on AC TIG actually. I like using AC on cast iron because it does tend to boil out any of the impurities. This should be a good grade of cast iron. Then once I've got it tacked, I can V out the centre, weld that or braze that, and then V the whole thing out, and so I can get it fastened together nice and strongly. It doesn't matter how neat it is because obviously it's going to get ground down and painted, filled, painted. The important thing is the fit up of it, and it does fit together really nicely. I might try and put a clamp on there just to hold it before I go near it with a welder. Anyway, we can only try it and see. Right, I've got a clamp on it. It's really nicely held together. So I'm going to try. get these two corners first. It's no use just putting a little bit on top of it. You've actually got to get into it and get some surface contact. So do these two first, see what it brazes like, and then start working on the centre up. Right, I've managed to get those two bits tacked together. I'm going to be a bit out in the centre and put a little bit in there, then I'll get the camera on so I can get some decent arc shots. The idea is not to melt the base metal because you don't want to weld it, because if you actually melt the base metal and the base metal alloys with this bronze, it forms some hideous, horrible, hard alloy that you basically can't do anything with. It's not looking too bad at all. So we'll finish veining this out. I'll set the camera up and so I can get some decent weld shots, because I know people don't like weld shots. I certainly do. Put some material on the inside just to try and stop it pulling. And you can see it's gone all the way through where I've ground it thin, so we've got really good penetration. We'll fill this in now and then we'll probably put some more on the other side. But hopefully it's going to make quite a sound repair. This is the rod I've used. And I'll show the machine settings. This is the machine I've used. It's an Lathe 260, TIG 260. I'll show you the settings. I've got it on AC, start at the beginning. I've got no pre-flow gas. I've got 25 amp start amps, no upslope. The main welding amps I've set to 146. I'll probably use no more than 90 to 100. Going to the AC part, I've got the AC balance set to 10%. Frequency 70 Hz, no downslope, no end amps, in 9 to 10 seconds of post flow gas. You could weld it on straight DC, but I find the AC cleans the material and you do get a better weld.